we got some features done. Some features done? Yeah. This is John, Joseph, Spencer, and Mario. Yeah, so let's showcase our app real quick. So you can convert it to, can we do like Command Plus to enlarge it, enlarge the text? It converts just regular text to DNA and RNA. It's quite simple. We have, at the very bottom, we have it logging, printing the timestamp for whenever you convert the string to DNA or RNA. That's the extent.
Can we talk a little bit about how we knew that this was going to convert to it? Okay.
Do it. Got it.
Well, I didn't want to do it. Okay. All right. So we were given two examples, right? We had, what did we have? We had we had A and we had cat, right? So we were given A as a string of characters. Like, well, what made that work? Well, we knew that this was ASCII characters, which could be written in decimal, could be written in hexadecimal. You can also do ASCII characters in binary. And it turned out that if you do a direct conversion of any arbitrary string, it'll always comes in, like, every pair is either going to be 0, 0, 0, 1, 1, 1, or 0, 0, 0. If I missed one,
1, 0.
1, 0. Someone's keeping track. So there's only 4 options, right? Okay, well, if we assign a mapping for each one of these characters, this one doesn't have, did we delete the comments? We might have deleted the comments.
That's the configuration.
That's fine. Well, this is the mapping that we deduced by comparing binary to the example 1 to 1. And I'm guessing this is the way that you guys all did it too. So it's not like I'm telling you anything new. But it's basically it's just a very nice site. So that was largely my contribution. I also did set up a flag so we can do RNA and DNA. And where's the encode function? That's what the encode as. Did we rename it?
Yep.
Yeah, there you go. And we got it nice as nice and slick there too. Yes.
So basically, as he mentioned, what is happening is that we took the string and we know that every time that we want to encode to the DNA format or encoding, as you may want to call it, we have to first know the encoding, the ASCII encoding for each letter or character. So we discover, as seen at the examples that they provide us in the problem, that, for example, A represented as 0, 0 could represent a 0, 0 in a byte.
The app, because it spits it out in the app. So we can actually punch in A.
Oh yes.
Yeah.
And that'll show exactly what we had in the original example, right? So
For example, here, as we're seeing, we know that when we encode in DNA, we will have the TGAT, which is basically a byte. If we transfer that to binary code, and that is exactly the representation for ASCII for that letter. So that's basically what we're doing. We know that at the end we will have an even number of these pairs of
every character should be
binary
represented with 8 bits, right?
Exactly. So there's an edge case that, for example, at least in JavaScript, when we convert the character here to the ASCII representation, it will spill out a decimal number, and then we have to try to convert that to binary. But sometimes we receive 7 bits, so
log is 0.
we fill the rest.
Bigger?
Oh.
No? Oh, I think it's around Visual Studio.
Control plus.
Yeah, we wish. Visual Studio should have a.
Yep,
there you go.
Right here. So this is what we are talking about. So when we convert that chart into a decimal format, because we know that we have a table, we have the letters, the decimal number, and then we have the binary, but we cannot convert directly to binary, so we convert firstly to decimal, and then using this function to string and passing it the base, we convert it to binary. And sometimes we receive, for example, something like, I don't know, this number, and that is specifically the code, but we know that we need to have a byte. So we fill out the rest of zeros so we can make a fair conversion into this encoding, because we have here in our map that sometimes that encoding may have zeros and zeros. So probably that's how everyone here did it. And yep, that's most of the problems that we could solve. We completed some other functions to solve the other problems, but we were not able to transfer them to the front end. For example, the code of the complementary, which is basically, as the problem in GitHub was stated, sometimes the A can be taken as the T, and the C can be taken as a G. So what we did is basically having another hash table, which is what we have here, and make that conversion. So
yeah, every character gets shifted forward by 2. It's mod 4, right? But again, we were working on getting everything hooked up, so not everything made it.
So at the end, to save time on execution, we just search for the correct string that we need to find, and then we just join accordingly, and that's basically how it works.
The guys on the front end,
Great.
talk about the front end?
Yeah, when I came up with the UI, basically, I was trying to incorporate as many features as possible at the top with the cards. I was hoping to incorporate the amount of characters typed in, as well as the time it took to output it, and a few others, but I didn't get to put that in there, so I just left the feature on the top. With everything else, as far as the color, I was trying to go for more like an eco-friendly type deal, since we were talking about DNA. That was kind of the idea behind it. And then I did my best to make it mobile responsive, but it didn't come out the way I wanted to because I forgot to add.
It came out perfect.
Great.
Always say the good things. You're good. You're good. We don't know it doesn't work.
It works.
It works. There you go. It works.
Team dynamic.
Can you bring up can you bring it up again?
Yeah. Okay, and then that's up. So I was hoping to code the HTML for the table, but I got so caught up with the CSS. So I was hoping that if you were to click on the table, that it would take you to a different template, and it's going to be an iframe, and it will show you a table of all the features that they had added for the app. That was one of my ideas. So, yeah, but that's as far as I got. Basic code.
You know what that looks like? First place.
Any questions?
Oh.
Anybody have any questions?
You guys are good.
All right, next group.
I still would
Don't worry, I'll end it with a banger.
Right now, once you get over whatever.
I mean, TATG, that gives you like
Yeah.
like TATG is the code.
And while they're getting ready, everyone keep in mind that we're going to be going through all the projects, and just like last month, I'll provide you guys, each team, a PDF with a breakdown of your scores. Okay? So you're not going to know who won today. You'll know tomorrow via Slack. Okay? And the winning team, I'll talk to you.
Still haven't got my shirt.
Hello all. We're just I don't think we even gave ourselves a team name. Just
Well, the awesomeness, that's our team.
and this is our implementation of the code here. So if you put like cat, DNA, there's an output there. We do RNA. There you go. So converted that. And what we did was we just put it on the table. Here you go. It's name. This is what it is. B. That's what it is. Just a simple lookup.
Smart.
Since it's just arbitrary, we don't really care what it was. So okay, you don't need to be fancy, just pop it in there. So, here's our code here. I'm gonna get a bunch of the rest.
Good. Open the
Yeah, there we go. There we are. And what we did was, when the person presses the button, it just uses the function, convert the DNA, plugs in the string for jQuery, grab that value, and then goes through a loop, concatenates the value, and outputs it. And if they were to select RNA, it takes the value of that DNA strand and replaces the T with a U since it's RNA. So that's what we did there. Other than that, I can't really think of anything.
That's fun.
Mm-hmm.
Any questions?
What about the front end? Did you guys talk about the front end already?
We were kind of confused about
the
class
front
and
end,
asking
yes,
questions,
we
right?
have-
The front end?
The front end? Yes. The front end we used Bootstrap.
Use some Bootstrap and some custom CSS. So since it's the Halloween season, that's why we choose the backgrounds of Halloween.
Very
And
good.
the button, we change the color to the purple because it represent Halloween. And we just do like a simple and fun design. So we all agree with the design.
Very good.
Yeah.
Any questions?
What's the volunteer?
Oh, never know. Thank you.
Have you seen it? It looks just like this. When did it?
It's in the, it's on the slide.
Followed my design.
It's, I just sent it on Slack.
Wasn't language used before?
Oh, genius. Looks easier. Hey, can you work at NASA?
Okay, so we are a three-man team.
Greg was supposed to do it.
We divided the work in three blocks: the UI, the JavaScript, and the Jasmine testing, the unit testing. Yes. And what we have here is just a simple page with the basic challenge text that I got from the repository. And we have a text box with an example cat. And then we submit whatever we want to submit here, submit. It will give us both DNA and RNA. So just the word. Goku? All right.
I have a question. I love your guys' design, especially how you guys use a set. It's like a 3-column layout on the bottom.
That is true. We did a 4 column. No, 4.
4 columns? Okay. Yeah, and then another thing is I can't read the font at all.
Oh, let me change that for you.
It's a feature.
We want to make sure you're paying attention.
Well, beyond-
Really dig in and look.
description, DNA is a very stable and compact storage medium.
Now to show a little bit about the back end.
Okay, so the way that we approached this guy was to generate the map. Basically, this is kind of horrendous looking, but what all that comes down to is we just kind of did it in order. So we used a five, I guess, DNA component sequence for every letter, and it just kind of loops through going, you know, the first one, the first ASCII character, which is a space, I believe, is AAAA. Second one is AAAC, AAAG, etc. So we just kind of went in order. And so that's what this crazy looking thing's doing. After that, we didn't get to the complement part, so that one's just kind of sitting there right now. But other than that, it was fairly straightforward. We had an array that was mapping the ASCII characters to those DNA sequences that were generated in that generate map function. And from there, all we did here was this guy right here basically just takes the original string, turns it into an array, and maps every character to its corresponding sequence that we got from the other function. And what it does here, so the bases are, this is if it was given a DNA sequence, it would use that first one, and that's gone through, here we go, strand types, so the strand type parameter. If not, you have your RNA sequence, and then from there, that's how it generates the map. So that's basically it for the functionality on the back end.
Any questions? Come on, Andy, what's your question?
You said you guys did testing.
Just keep in mind, I will ask that question of your project.
Okay, you said you guys did testing. Can we see it or not done? Okay, I'm sorry.
You know, you can see it, but it don't work.
Okay.
No, actually, I spent a good portion of the time kind of on the wrong thought track, and so by the time I realized it and had to switch directions, I ran out of time.
Okay.
So there's pretty much.
But she tried very hard. Yeah, she went really hard.
I would have gotten it with another 3 hours.
It was really good idea. She did a good job.
Any other questions? Got it. Cool.
Thank you.
You guys go next? That's fine. I think we have one for next. Do we have the connector? For what?
Do we have this integrated?
We have a connector for Mac, by the way.
The reverse conversion.
That was at 6.
Why? Did you see
It's actually, I think it's 5. It's like you should be able to
She is.
recognize strings.
You know, it's like
You guys, if you need more time, let me know.
Yeah, I need more time, Joel.
No, not you. You had like 20 people on your team. I bet it's like a production right now.
22. Come on, I get it ready. Next time I'm just outsource to India, bro. Who cares?
Hi, we are Team Try Brains. Because honestly, that's how we were kind of feeling during the project. So, but yeah, over here we have very minimalistic interface. So, you want DNA? Someone give me a word here.
Goku.
Butterscotch.
Cat.
What?
Goku?
Goku? I heard Goku. Okay, so we type in Goku. And we hit submit, and there's the DNA string. Okay.
That word for RNA.
But does it do RNA?
Yes, that's a very good question. There you go. Want to do Goku again?
Yeah.
Can we do eukaryote for Venom? How about that?
Okay, Venom, sure.
I just want to say super long string.
Just that big cut.
So super.
Oh my.
I can't spell today, okay?
You know what it's spelled?
No, it's not a word.
Expialidocious.
Yeah.
I don't know how to spell that.
We still have some bugs to figure out.
It's a feature.
Yes, because this explains how crazy it is that we have DNA this long. So, my name's Rebecca. As team lead, I help write the function for getting the DNA and RNA. Daniel over. So he worked on the front end.
Yeah, the style sheet was broken, so I couldn't do anything for like ever, like less than minutes. So.
And Jimmy over here worked on testing. Okay.
Very cool.
So we can show you how we did the DNA algorithm. Oh yeah, we also have log back here. So,
Very
yeah. Got a timestamp. We have what functions run, and also apparently it takes about less than a millisecond to complete for each one. So,
Very cool.
yep. So if we look in the DNA over here, so we put two arrays, one for DNA, because index 0, 1, 2, 3, and same for RNA. Since what we're doing is we're taking in an input, and then we convert it to base 4 from the ASCII character code. And since then we have 0, 1, 2, 3, and then we just match it up with whichever array depending on if it's DNA or RNA. Yep, so, yep. We also have our
Basically, this is the line that does it. That's how you convert one to a base 4.
we also wrote a test suite.
A test? Wow.
Yeah, let's take a look at.
Yeah.
So, yeah, so I think he was working on some other tests, but.
Right, we were trying to reverse it, so. But I almost got it working, but there was some problem converting.
Welcome to the club.
Yeah. Are there any questions?
So Daniel, what did you use for the front end? Any other questions?
I love it.
Aw, dang.
Good question.
Yes.
Just wanted, well, would like to see or if you can briefly explain the base for logic. It interests me a lot.
Yeah,
Since
so.
we work with base too.
Yeah, I noticed that.
So
We're using base 4.
Yeah. Click DNA down. Not that one. Okay, so the reason why we using base 4 is because for each character we take in, we convert it into 4 of those DNA letter things. So, so we have like 4 of those. So if we convert to base 4, then we have 0, 1, 2, and 3, which allows us to just plug into an array and then call it a.
So you just cut to the chase.
Yep.
The 4 options, you just stuck with mod 4.
Yep.
I like it.
I like it too. Okay, that was my question.
Okay,
Thank
cool.
you.
Do you have any more questions?
No?
Yeah, what is your question?
If you were to develop this for maybe 10 more years, do you think you could actually output an entire string of DNA or prints out an actual cell?
Well, we would need to hook it up to something that actually prints it. out cells, but maybe.
They're working on it. They're
Yeah.
working on it.
Yeah,
We're going to need like maybe several shipments of 5-hour engineering.
I think it actually codes things a lot more complex than ASCII characters though too, so.
They're working on it. They're working on it. Perfect. Anyone want to volunteer? Oh, perfect.
Sure.
What?
Hell yeah. What question is that, bro? Hell yeah. What kind of question is that, bro?
I'll just stay.
There's like 20 of them. I was trying to. Where's my shirt? I really wanted us to be able to actually output the most seconds to the top. I was gonna say compile times. The top.
Oh, actually, my browser history real quick, guys.
I'm like working out.
So, Tony gone.
There you go. Is it really?
Yeah.
Wait, who's David?
Oh shit.
Always disappears.
I think he went to the cards.
Yeah.
Go find out.
Oh, shut up and present.
Hey, we're waiting for
Where is Tony?
Tony bathroom.
And David? Oh my god.
Yeah, I think they're talking to each other.
Well, you know what? You have enough people. It's fine. You volunteered. You volunteered.
Here they are, then just flushed.
Were you just stalling until you heard the flush?
Yes.
Wonderful.
They're in there working on the last component. DNA sample.
Wow.
We're presenting. Yeah.
So are you trying to say that your code is crap?
That's a wonderful way to start. So, I love it already.
Hey, what's up, guys? We're Fortnite for life. Obvious reasons, but we got Ryan, Tony, Jessica, Sarah, Greg, and David.
And you.
And Andy.
Oh, and me.
Oh, shucks.
And, so we did actually get our application pushed to Heroku. So this is live. But don't
You guys
press it.
can go there?
No. Don't go.
No? No good?
And it has a max of 10. Up to 10. Yeah, it goes to max 10.
Alright, max 10. 10 people can go there.
Alright, so pretty basic. Put in cat. Converts it. Boom. We also did a capital. So it's different if you do a capitalize. Boom. And then with sentence, cat is a cat. Boom. It's too easy out here.
Dude, that only works on Fortnite. These people are here. They're gonna get you. So.
Okay. And then we did RNA as well. So we do cat is cat. Changes everything. Alright, so you guys understand basic? So we go over the code now. And
Can you do cat again?
what? No, it is. We did our own style. We didn't copy your style.
Well, how did you get
We're gonna go over that right now.
Okay.
Alright, chill out. So Sarah and Greg worked on the code, so they actually created functions, converted to a binary, and you guys can explain it. Yeah, it's probably explain it better than I can.
Okay, so so what we did first was we converted the character to ASCII in a string, and then once we got an ASCII, we converted it to binary, and then from binary we split it into 2 bits, so that every 2 bits was equivalent here. So it's 0, 0 is equivalent to A, 0, 1 is equivalent to G, then 1, 0 is C, 1, 1 is T, and then we just combined it at the end. And that's how we did it. And then we were working on converting it reverse converting it. So we got it working, but only for one letter. So you can't do it as a word. So if we put in GAAG in the code, so if you like console. That's
It'll
fine.
only give us A.
So it'll give you GAAG is equivalent to A based on how we set it up. So based on how we deciphered it.
Okay. So the mapping's just transposed for a couple of characters.
Yeah, for the 4 DNA bases. Yeah.
Well, it's the same way
So
you
for
guys did it,
0,
right?
1, yeah, 0, 1, 2, 3.
No, that's like arbitrary. No,
Yeah.
no, I see,
Yeah,
I see
yeah.
what you did.
Yeah.
I think
Yeah.
you're right.
Can you show us the logs?
Yeah, so it also does logging. We have a whole, so it actually calls a back end that's on Heroku, so it's obviously got a back end. But we set up, so logging is done by Winston, and then it logs to Papertrail, which is like an add-on administrative logging system for Heroku. It also writes to a text file, doesn't it? But we actually, we went with this implementation at the end for this particular, like the way we set up the actual route, but we have the code for logging just to a text file if you want to just keep a record of it.
Yeah, so if you go to VS Code, and then go into logs, the folder. Yeah.
Oh, yeah.
Scroll all the way down.
Oh, wait.
Yeah.
Click on like the lowest file.
This first, and then, yeah.
So
Yeah, so this would be logging to text.
And then logs the time as well.
Logs the time to complete the computation. That's done actually in Papertrail. I don't know if we included it in there. Oh yeah, we did, because we, yeah, it's on Winston.
Yeah.
So yeah, it logs both the string and the time to compute.
I haven't seen that transparent thing before for Visual
You see
Studio.
the time per year? 4 to 1.
Yeah,
And
for
then-
January, I think it's just
See that?
the week system.
What else can we show you?
And then we also got testing. So if you want to sample
Yeah.
NPM, what
Got a
is
little
it?
jest.
NPM watch them?
Test.
NPM test.
Test that.
Watching like everything failed.
What? It's still testing. Still
Oh.
testing. Sweet.
Sweet. I love the commentary.
Sure test found.
Oh,
yeah,
you're in the wrong direction.
Oh, need that right director.
Pretty sure. This is the right one. I don't know what happened.
It was working, right?
Do you guys mind explaining what just happened?
It's a feature.
Did they pick up quick?
Just give it up.
No, no. You gotta press more often. See.
What? Yeah. Do you know?
Me?
What? Yeah. Did you see something?
Oh no, you're the one with the production team over there. Got like 20 people, you told me.
Alright.
Perfect.
Alright, we're done.
Alright, well, we wrote the test. They just don't.
No, they work. I don't know why it's not working.
So the test was just for what, the timestamp?
Let's make sure that our functions work, that are actually converting to what they're supposed to be. So you see if we input
Okay,
cat.
well, you can still print to the screen though, for any, in the app.
Yeah,
Right, but that's what tests do.
that's when you test it.
That's unit testing.
Can you pull up one of the tests?
What do you mean? These are all tests right here.
Those are the
So
tests.
doing it
Yeah.
programmatically allows
Which
you,
test
so if you
did
go
you
in and
use?
break something later on, if it's done programmatically, you can just run all the tests, so you don't have to like sit there and go through each individual one.
Did you say you use Jest?
Yeah.
Yeah.
These are all done through Jest. And then I want to talk about the front end.
Yeah, I mean, the front end's pretty simple. It's just Bootstrap with a UI library called Argon that handles the little clicky thing here.
Oh, the radio?
Yeah, the radio button.
Let's see this.
Yeah, that works.
Alright, any questions?
Please have questions.
Alright, well.
I don't know.
No
Yeah,
questions?
you gotta have some questions, come on.
Okay.
Well,
What is
yeah.
paper
Who
trail?
worked on what? What's paper?
Oh, what's that?
That's good.
Who worked on what?
Yeah, we'll do.
Do paper trails. He wants to know what's paper trails first.
Oh, what paper trail is? So paper trail is it's a just add-on to Heroku that is for logging. So instead of like outputting everything to a text file in which we normally do for logging, so like if you have a backend, you probably want to log every single HTTP request because if someone is, let's say, breaking into your system, you want a record of, you know, that transaction. And it's good for tracking down bugs and all that kind of stuff. So you could output it all to one giant text file, and I think a lot of companies do that, right? But Papertrail gives you a little more functionality with just allowing you to like search through your logs and, you know, be able to find things by a certain date stamp or things like that.
Cool. Is it only work with Heroku or can it be with this one?
Good question. I don't know, because I've only seen it in Heroku, but it might be a standalone program. You guys know?
I don't even know who you're looking at.
Yeah.
That's point at me. No, I don't know.
That's for
What do you guys use for like logging?
So it depends on the stack. For example, LambStack has its own way of doing it. You
Yeah.
have a log file. So log files are not meant to be ginormous. You rotate them, so you clear them out, right? So
Yeah.
Is it automatically?
And that's what something like Papertrail does, is that it automatically does that sort of back-end stuff for you. So it will archive old logs and whatnot and keep
What I
keep
currently
new
do
ones.
is use Bash to look into the logs. I
These are
like the
Winston
paper
Paper
trail
log,
here.
yeah. Yeah,
Because I
It's-
mean, it probably generates indexes.
Yeah, exactly. And then anything you console log will also get logged in there. Now, we used NPM package called Winston that adds a little more functionality to it for logging,
Yes.
but you could just console log everything and work the same.
It's a sort of, it's, you have to pay for that, right?
I think you get a certain amount of backlog for free, but I don't know how much it is.
Yeah, that's where we separated. We have Ryan being the project manager, kind of like the lead. I did testing. Greg and Sarah worked on the converting it to a DNA and RNA. Jessica was a shadow. Tony did most of the server code as well as Winston, and David was helping him as well.
Where do you see yourself 10 years from now? If you were to
Interview question?
Yeah.
I always want to run a zoo. Or a farm, yeah. Farming, something. Yeah, something.
Something doesn't have to do with code.
Yeah, as long as it doesn't have to do with code. No, yeah.
Coming from real life.
Yeah. No, I mean, honestly, like, I don't know. I
I'm
like
a big
medical
bone
stuff.
and ridge.
I like machine learning and medicine and stuff like that. I think there's a future there. What about you guys? Farm.
Farm with Ryan. Anyone else?
Yeah.
Any more questions?
Perfect. So we have one more team.
Alright.
How many people were in here? Joe?
Test one was broken.
Did you work on that?
Yeah.
Oh, that's what it was.
Oh,
there it is.
Yeah. I suppose that's gotta be. What did fail?
One, do we have pre-made repositories?
The one that works.
Doc over GitHub to submit our projects, or how's that work?
No.
Too late. That's minus 6 points.
enjoying all these background screens.
Why are you guys like all separated?
Sorry, change my resolution.
Pretty much.
Oh. Never mind, looks a lot different. So we're Team Slackathon. Scott, Catherine, Manuel, Kieran, Nick. So, Manuel and Kieran worked on the front end. Nick managed the Git repository, make sure that we didn't accidentally overwrite everything like we had issues with on our first project.
We had a lot of beginners on our team, so like we were trying to work through a lot of stuff, had a bunch of different ideas, like what we should do and how we should combine our talents.
Yeah, we spent a good bit of time just trying to figure out what the heck we were supposed to be doing. Like probably at least an hour. Just trying to understand what it meant to convert ASCII to a DNA sequence, and we finally worked it in Python. Unfortunately, we didn't get, well, we got a front end for entering text. It enters the text, saves it as a text file. We were going to do the actual back end of it in Python, but we didn't get a chance to integrate the front end and the back end because, once again, never worked together, don't know what we're doing, and we're all fairly new, beginner level at this. So, you know, so we got the front end. They got it to save the input as a text file locally. It doesn't output the result because we couldn't tie it in with the actual engine to do the conversions.
We'll do it on the console.
Yes, and everything will work on the console.
Let me see.
That's what I'm going to do right now. So we did get it. Sorry, I changed the resolution on my screen and I'm having a lot of trouble seeing this. So enter a string of ASCII characters. It only processes the first 128 ASCII characters, just because the second 129 through 255 are really weird control characters that don't really. Yeah. So it only processes it. Well, it will process them, but there's no way to input them. So. And it just outputs the DNA strands, or the DNA sequences. We did something similar to how,
Okay, you give us a short essay on the quote.
On what?
On the quote.
I don't know, I was thinking of Winston Churchill and then got distracted.
Now is the time for all good men. Blah, blah, blah.
Yeah, something like that. I got
We
distracted
will code it
halfway
on
through
the
it.
beaches.
So this is done in Python, 4 hours to write 45 lines of Python, if it opens up. So it breaks down the 4 AGTC into the binary representations. It's actually an 8-bit binary number. Each letter can takes up two bits. So you've got basically the 4-letter combinations is 255 possible outcomes, which is the entire ASCII library. Yes, so 4 hours, 55 lines of code, sorry. This is the whole thing for converting strings into Python. What it does is it takes the string through the input and processes the string to convert each character in the string into the ASCII value of the string. So here you're taking the string. This is done in Python, so it's using the Python looping methodology. So you take each character in the string and you convert it to the ASCII number, which is a number between 0 and 128 in this case. From there, we take the ASCII number and convert it into a binary number, but we convert it into a string as opposed to leaving it as a binary number, because it's a lot easier to do comparisons and substitutions for strings than it is to try to manipulate binary if you're not used to thinking in base 2. So we've got a couple of methods here. This is the method that encodes it. It basically, for each binary possibility, it creates the DNA representation, ATGC. So when you run the code, it actually matches what? So for example, A, and it's TGAT, which is what it was supposed to be. Cat is the same way. However, A, capital A, is TAAT. So it differentiates between case sensitivity. It'll also convert any printable character into a DNA conversion. So control characters, brackets, whatnot.